Hi, welcome again. My name is Sherlina Leah Rivera. I'm from BSc 3I and my subject is Dynamics of Rigid Bodies. And, ha- and I have a topic in rigid bodies which entitled Relative Motion Acceleration. To further understand this topic, let's try to solve some problems. Example number one, a wheel of radius r rolls to the left without slipping. And at the instant, consider the center O has a velocity v sub O and an acceleration AO to the left. Determine the acceleration of points A and C on the wheel. For the instant, consider this figure. So I personally drawn this figure, which is the wheel that has a contact, of course, with the ground, and it has a angular velocity, angular acceleration, angular with sub O, and we have the O, which is the origin. We have to the left, which is the velocity sub O, and we have point A, and we have the theta and the point C. So let's start to solve. So to properly start, hello. So if we remember in the previous problem, we knew that the angular velocity and angular acceleration is denoted as this one. Angular is equals to, sorry for that. So angular is equals to V sub O R, and acceleration is A sub O divided by R. So this is angular velocity and this is our angular acceleration. So as you can see here in the problem or in the figure, there is no numerical value. So we are about to solve in variables. So back to the solution. So the acceleration is written in the terms of A sub A equals A sub O plus A to O. This is also equals to A sub O plus A to A and to O, and normal plus A to O tangential. So this is the acceleration in terms of this. Acceleration at point A. So this is the sub, which is simply means point A. So they have a magnitude of acceleration A to O normal and acceleration A to O tangential. So normal is equals to R sub O angular squared, and the tangential acceleration is equals to R sub O alpha. So this is equals to this normal acceleration is equals to R sub O V sub O R squared. So why it is if we go back here, it is also here. So the angular is also V sub O R. So we're just substituting the value, which is also here. So R sub O, so therefore the alpha, I'm sorry. So therefore the alpha is alpha AO all over R. So we're just going to replace. So R sub O, A sub O, R, and that's it. No squared. So that is our magnitude. So using the head to tail method, this will lead us to AA. So later on, I will show you the head to tail method graphically. So the algebraic can be expressed as AA is equals to AA normal squared plus A at point A tangential square. So what is the value of this normal and what is the value of this? So let's solve. So A normal and A tangential. So for normal, we have A sub O cosine theta plus A sub A to O normal, and we for tangential we have A equals to A sub O sine theta plus A to O tangential. If you notice, this is cosine and this is sine theta. Simply because tangentials are perpendicular and vertically positioned in the graph. I'm sorry, not in the graph, but in the figure. So later on, I will graph it. So after getting this value, so we can simply now substitute the values that we gathered here. So I will just solve here. So A sub A is equals to A sub sorry, this is A sub point A. So the value of this is this one. So AO cosine theta plus A to O normal squared. Then simply substitute here, up here, and then put it. So it cannot be seen, so I'll just put it here. So plus AO sine theta plus A to O tangential. So we can simplify this by here, by using this one. We have A is equals to A cosine is normal, so we can use the R alpha cosine theta plus R AAON is also equals to this one. R sub O angular squared. Squared. So this one is squared. And plus substitute again the value. So we have R alpha sine theta plus R sub O angular alpha squared. So that would be our magnitude. But that is not the end. So the terms, considering a point on the wheel, you can get an expression, which is AC is equals to AO plus A to O. So the terms will be added. So from here, A to O, the terms will be added. So A to O N is equals to R angular squared and A to O tangential R alpha. So AC, so plus this one, normal and tangential. Since we don't have value, we can answer variable R angular squared. So this is our final answer. So to further elaborate the figure or the wheel, let us now move on. So I'll just get the pen. So now we're going to elaborate the head to tail method, of course. So since it is a head to tail method, So from here, did you see it? Here. So here's a point, then here, and then lastly here. So what are those vector does represent? So for this one, we have our tangential, and for this one is our angle theta. This one is our acceleration at point A, and this is acceleration at O. And this one is our acceleration A to O T. So this one is acceleration. So as you can see, this one A to A O normal. So the tangential is perpendicular to the normal. So to further simplify this, imagine this is the O, point O, point O to point A. So from point O to point A, we have here normal and then tangential. So for the tangential, So for the tangential, we have A to O, T equals R sub O alpha. Then at point A, we have the path of point A, which is this one, which is colored yellow. And then this A, the normal is value as AA to O, normal is equals to R sub O angular squared. So what if we twist the O to A, not just simply twist, but to have different coordinates? Have two different coordinates. Sorry for that, guys. So A to O, and then we have here O, which is, this is our normal, and this is our O to C. And this is our normal. This is our tangential. So for our tangential, we have AC to O, T is equals to R alpha. Our normal value here, as you can see, the normal values here is A to C, C to O, acceleration C to O, normal is equals to R angular squared. So by graphically, you can solve it and you can get the answer, but careful with the direction, of course. So we can more simplify this by simply here, and here. So this one, the box, which is composed of 4 vectors, this is simply the relation, or this one is AO, R alpha, and this one is our A to C, R equals to angular squared, and this one is A to C to O, tangential equals to R alpha, and lastly the A to C O normal is equals to R angular squared. So that's it for the graph. So it might be confusing at first since we don't have value, but it is mostly substituting the variables. So that's it for today, and thank you.